Hello and welcome to the Sleep Science Space. I'm really glad you're here with me tonight. Out in the world, things can feel fast and overwhelming, but here we slow everything down. This is a quiet place where your mind can rest while curiosity gently drifts in the background. Forests are among the most remarkable environments on Earth. They are far more than collections of trees. They are living systems that breathe with the planet, shaping the air we inhale and the climate that surrounds us. Some forests are so vast and dense that they create their own weather, releasing moisture into the sky and calling clouds back again. Some trees have stood in silence since long before the pyramids were built, watching human history come and go beneath their branches. Beneath the forest floor, unseen networks of fungi connect roots across great distances, allowing trees to exchange nutrients and chemical signals through the darkness. In the Amazon, more species coexist than anywhere else on the planet, forming one of the richest ecosystems Earth has ever known. Across the frozen taiga forests stretch for thousands of kilometers, quietly storing more carbon than all the world's oil reserves combined. And in high mountain cloud forests, moisture drips straight from the air into leaves, branches, and moss, as if the sky itself were feeding the land. Forests are ancient, they are powerful, and they are endlessly full of quiet surprises. Tonight, we'll take a gentle journey through 100 fascinating truths about forests and the hidden systems that keep them alive. If these calm explorations help you unwind, you're welcome to like or subscribe or share the hunt below. It helps others find their way here too, one sleepy soul at a time. But for now, you don't need to do anything at all. Let your shoulders relax. Let your breathing settle into its own natural rhythm. Imagine the stillness of a forest at dusk when the light softens, the air cools, and the canopy slowly closes above. And when you're ready, we'll begin. The largest living organism on Earth isn't a whale or a towering tree. It's a forest fungus. Beneath the soil of Oregon's Blue Mountains lies something almost impossible to picture at first. Above ground, the forest looks ordinary. Trees rise, leaves fall, and life moves quietly along. But below the surface stretches a single living network spreading through the earth like an underground web. This organism, known as Armillaria ostoyi, covers nearly 4 square miles and is believed to be thousands of years old. While its mushrooms appear briefly above ground, the true body of the fungus exists below, formed from countless microscopic threads called mycelium. These filaments weave through the soil surrounding roots, sharing nutrients and slowly expanding year after year. Scientists consider it the largest living organism on the planet, larger than any animal reef or forest of individual trees. What makes it truly remarkable isn't just its size, but its patience. It grows quietly unseen, reminding us that some of the greatest forms of life exist far from view, thriving beneath our feet. The Amazon rainforest alone is home to roughly 10% of all known species on Earth. Spanning 9 countries and millions of square kilometers, it holds an extraordinary concentration of plants, animals, insects, and microorganisms. Many of them have yet to be fully studied, and some have never even been named. Within this vast green world, life layers itself, from the forest floor to the highest canopy, creating a living mosaic unlike anywhere else on the planet. Roughly 1 out of every 10 species on Earth calls the Amazon home. That means millions of plants, animals, insects, and fungi sharing space beneath a single towering canopy. Life here is layered in every direction. Jaguars move silently along the forest floor, while pink river dolphins glide through winding blackwater channels. High above orchids cling to branches, drawing moisture straight from the air. Below ground, entire civilizations of ants tend underground fungus gardens, farming in darkness with remarkable precision. Scientists believe the Amazon still hides countless forms of life that have never been documented. New species are discovered every year, and many more likely remain unseen. This forest is not just diverse, it is dense with life stacked from its shadowed soil to its sunlit canopy. To walk beneath its trees is to step inside a living encyclopedia of the planet, written not in words, but in leaves, calls movements and breath. Far to the north, another forest quietly shapes Earth's future. The boreal forest, stretching like a green crown across Canada, Russia, and Scandinavia, may not capture the imagination in the same way as the Amazon. Yet its influence is immense. Beneath its vast stands of spruce, pine, and larch lies one of the planet's greatest carbon storehouses. Much of this carbon is locked away in cold soils, wetlands, and thick layers of moss and peat where decay happens slowly. Scientists estimate that the boreal forest holds nearly twice as much carbon as all the world's known oil reserves combined. For centuries, it has acted as a powerful brake on climate change, quietly absorbing and storing carbon year after year. But this balance is fragile. As temperatures rise, permafrost begins to thaw, risking the release of ancient carbon back into the atmosphere. In this way, the boreal forest is like a vast vault, and the stability of Earth's climate depends on keeping that vault sealed. The Amazon rainforest doesn't only depend on rain, it creates it. Each day, countless trees draw water from deep within the soil and release it into the air through tiny pores in their leaves. This invisible moisture rises, cools, and gathers into clouds that drift across the forest before falling again as rain. Scientists call this process evapotranspiration. In the Amazon, it forms an atmospheric river cycling water repeatedly over the same living landscape. A single large tree can release hundreds of gallons of water into the air in just one day. Multiply that by billions of trees, and the result is a self-sustaining weather system. The forest feeds its rivers, fuels its storms, and even sends moisture far beyond its borders, influencing rainfall thousands of kilometers away. The Amazon drinks and rains in the same breath. It is a living engine powered by leaves, roots, and sunlight. Beneath nearly every forest lies another hidden world, a vast underground network of fungi linking tree roots together. Scientists often call this system the Wood Wide Web because it allows trees to exchange information and resources through the soil. Through these fungal threads, a young sapling growing in shade may receive nutrients from an older sunlit tree nearby. When insects attack one tree, chemical signals can travel through the network warning others to strengthen their defenses. Carbon, nitrogen, and even water can flow from one root system to another, binding the forest into a shared community rather than isolated individuals. What appears above ground as a quiet stand of trees is below the surface a living conversation, slow, subtle, and constant. A reminder that forests are not collections of solitary lives, but deeply connected systems cooperating in ways we are only beginning to understand. Some trees appear to play a role much like elders within the forest. Through underground fungal networks, they quietly channel energy, water, and nutrients toward younger seedlings growing in shade. These mother trees do not nurture through intention or emotion, but through chemistry and connection. Carbon-rich sugars move along fungal threads, sustaining fragile new life until it can reach the light on its own. What seems like a silent woodland is beneath the soil, alive with exchange. No voices, no movement we can see, only molecules traveling slowly from root to root. The forest, it turns out, is not a collection of individuals, but a cooperative system bound together by threads thinner than a human hair and older than memory. Some of the oldest living trees on Earth began their lives long before the first stones of the pyramids were set in place. High in the mountains of California and Nevada, bristlecone pines cling to rocky slopes where few other plants can survive. Twisted by wind, bleached by sun, and shaped by centuries of snow, these trees are the oldest known individual organisms on the planet. Some are nearly 5,000 years old. When these trees were young, human civilization was just beginning to take shape. They have lived through the rise and fall of empires, through long droughts and bitter ice ages, through lightning strikes and centuries of silence. Their survival does not come from rapid growth, but from patience. They grow slowly, adding only the thinnest rings each year. Their dense resin-filled wood resists insects' decay and time itself. To stand beside a bristlecone pine is to stand beside history made alive. A reminder that for trees, time does not rush. It waits. Yet even forests that feel eternal can reach a breaking point. For all its immense size, the Amazon rainforest is more fragile than it appears. Scientists warn that it may be approaching a dangerous tipping point. As deforestation spreads and climate change dries the air, the forest's ability to generate its own rainfall weakens. If that cycle breaks, vast areas of rainforest could shift into a drier, savanna-like landscape. This transformation would mean fewer trees, less rain, and a cascading collapse of the systems that have sustained the forest for millions of years. In some regions, the Amazon already releases more carbon than it absorbs, reversing its ancient role as one of Earth's greatest carbon sinks. If the forest crosses this threshold, billions of tons of stored carbon could be released into the atmosphere, accelerating global warming. Countless species would lose their habitat, and climate patterns far beyond South America would begin to shift. The Amazon's fate is not isolated. It is woven into the balance of the entire planet. Africa's great rainforest holds a similar, quieter power. Second in size only to the Amazon, the Congo rainforest is often overlooked. Yet beneath its canopy, lies one of the largest carbon reservoirs on Earth. The forest itself, along with its vast peatlands, stores more than 80 billion tons of carbon, more than the entire United States emits over an entire decade. Much of this carbon is locked away in waterlogged peat soils where decay happens slowly due to a lack of oxygen. These soggy layers have accumulated over thousands of years, quietly storing the past. But rising temperatures and human disturbance threaten to dry these peatlands. If they are exposed to air, the stored carbon could be released rapidly with global consequences. The Congo rainforest stands as a reminder that some of the planet's most powerful climate safeguards are also among the most vulnerable. Forests do not shout their importance. They work silently, patiently, holding balance until that balance is disturbed. For now, the Congo rainforest remains one of Earth's quiet guardians, a vast green stronghold absorbing carbon, cooling the air, and holding back the rising tide of climate change without sound or spectacle. It does its work silently, leaf by leaf, root by root, asking nothing in return. The tallest trees on Earth rise higher than a football field is long. Stand at the base of a coastal redwood in California and look upward. Your eyes climb the trunk, past the rough cinnamon-colored bark, higher and higher, until the crown disappears into mist. Some of these trees soar more than 370 feet into the sky, making them the tallest living beings on the planet. To imagine their scale picture, a football field lifted upright. The redwood stretches beyond even that. High above the forest floor, entire ecosystems live in their branches. Ferns cling to bark. Moss carpets thick limbs. Small salamanders spend their lives suspended far above the ground, never touching soil. These giants thrive in narrow strips of fog-laced coastline where cool air meets the Pacific. They drink not only from rain, but from fog itself, drawing moisture directly through their leaves. Despite their immense size, redwoods are surprisingly vulnerable, surviving only where climate conditions remain just right. And yet they stand as symbols of nature's quiet ambition reaching upward, century after century. Redwoods can live for more than 2,000 years. Beyond their height, redwoods are masters of endurance. Some individuals have lived for over 2 millennia, witnessing the rise and fall of civilizations far beyond their forested homes. Their thick, fibrous bark resists insects and insulates them from fire, allowing flames to pass without ending their lives. When fires move through redwood forests, they often clear away smaller trees while leaving the giants standing. Their roots, though shallow, spread wide and intertwine with neighboring trees, locking the forest together into a shared foundation. Each tree supports the others. A grove becomes a single living structure. Walking among redwoods feels like entering a natural cathedral. Pillars rise into fog. Sound softens. Time stretches. These trees do not hurry. They endure, and in their rings, they record centuries as calmly as breath. Cloud forests drink directly from the sky. High in mountainous regions where mist gathers and lingers, cloud forests exist in near permanent fog. Here, trees have adapted to harvest water straight from passing clouds. Leaves, mosses, and branching limbs comb moisture from the air, turning vapor into droplets that fall gently to the forest floor. Even when rainfall is scarce, these forests continue to drink. The captured water feeds streams and rivers below, sustaining ecosystems and human communities far beyond the forest itself. In this way, cloud forests act as living reservoirs, pulling life from the sky and sending it downhill. To walk through one is to move inside a breathing cloud. Every surface glistens. Every step is softened by moss. The air feels alive, heavy with moisture and quiet energy, as if the forest itself is inhaling and exhaling around you. Some forests glow softly at night. In certain places, darkness brings an unexpected light. On fallen logs and damp forest floors, tiny mushrooms emit a faint green glow, like scattered stars resting among the roots. This phenomenon, known as bioluminescence, comes from chemical reactions within the fungi themselves. The glow is gentle, never harsh. It may help attract insects that carry spores, allowing the fungi to spread. Or it may simply be a byproduct of survival in the dark. Whatever its purpose, the effect feels almost unreal. To encounter a glowing forest at night is to step into a quiet dream, a place where the ground itself seems to remember light, and where the forest reveals yet another secret after the sun has gone. As the young plants rise, they take advantage of the open sky above them. With the canopy temporarily thinned, sunlight pours down to the forest floor, warming the soil and fueling rapid growth. In a surprisingly short time, green returns to places that once seemed reduced to ash. This cycle has repeated itself for thousands of years, shaping forests that are not fragile but resilient, adapted to change rather than frozen in one state. Forests can cool the planet around them. On hot days, a forest can feel noticeably cooler than nearby open land. This isn't an illusion. Through shade and evaporation, trees actively lower the temperature of the air around them. As water moves from leaves into the atmosphere, it carries heat away, creating a natural cooling effect. Large forests can reduce regional temperatures by several degrees, influencing local weather patterns and even softening heat waves. In cities, small patches of trees can lower surface temperatures dramatically compared to bare concrete. In this way, forests act like the planet's natural air conditioning system, quietly regulating heat with every breath of moisture they release. Trees can influence rainfall far beyond their borders. The moisture released by forests does not simply fall back down where it started. Air currents carry it across continents. In South America, vapor rising from the Amazon travels thousands of kilometers before falling as rain in distant regions. This recycled moisture feeds agriculture rivers and reservoirs far from the forest itself. When forests shrink, these invisible rivers in the sky weaken, altering rainfall patterns in places that may never see the trees directly. A forest, then, is not only a local ecosystem, it is part of a planetary circulation system linking distant lands through the movement of air and water. Some forests grow on floating ground. In wetlands and floodplains, forests can take root on mats of vegetation that drift atop waterlogged soil. Over time, grasses, shrubs, and eventually trees anchor themselves in these floating layers. Their roots weave together, trapping sediment and strengthening the mat beneath them. These forests rise and fall with changing water levels, neither fully land nor water. To walk among them feels slightly unreal, as if the ground itself were breathing gently, shifting beneath each step. Forests can shape entire landscapes. Over long stretches of time, tree roots break apart, rock stabilize slopes and prevent erosion. Leaves that fall year after year build deep soils, transforming bare ground into fertile land. Rivers that flow through forests tend to run clearer, filtered by roots and soil that slow and clean the water. Remove the trees, and these systems unravel. Soil washes away, slopes collapse, streams grow muddy and unpredictable. Forests are not decorations on the land. They are engineers quietly constructing and maintaining the terrain itself. Some trees survive by sacrificing parts of themselves. In harsh environments, survival sometimes means letting go. Certain trees can shut down sections of their own tissue during drought or extreme cold, allowing branches or even large portions of the canopy to die back. By doing so, they conserve energy and protect the core of the tree. When conditions improve, new growth emerges. What looks like damage is often a calculated retreat, a strategy refined over centuries of stress and recovery. Forests hold memories of the past. Tree rings record years of abundance and hardship, wide bands marking wet seasons, narrow ones recording drought. Fire scars etched into trunks tell stories of past blazes. Even chemical signatures in the wood can reveal ancient volcanic eruptions or shifts in atmospheric composition. By studying trees, scientists can reconstruct climates stretching back the thousands of years. Forests are not just living systems, they are archives quietly preserving the history of the planet in wood and fiber. Some forests are older than nations. Long before borders were drawn or cities were built, forests stood where they still stand today. They have outlived empires, languages, and entire ways of life. While individual trees eventually fall, the forest itself persists, regenerating again and again. To walk through such a place is to step into continuity, to feel the presence of time moving at a slower pace than human lives. And as night settles in, forests do not fall silent. The sounds change. Leaves rustle, insects sing, distant calls echo between trunks. Beneath the ground roots continue to grow fungi, continue to spread, and water continues its slow movement through soil and stone. Even at rest, the forest is never still. As you breathe now, you might imagine yourself standing among tall trees, the air cool and scented with earth. Light fades, shadows lengthen, somewhere above branches sway gently, and somewhere below life carries on unseen. Forests remind us that strength does not need to be loud, that endurance can be quiet, patient, and deeply rooted. You can let that feeling settle in. There is nothing you need to do. The forest has been here long before us, and it will continue long after. For now, simply rest within the thought of it. Let your breath slow, let the canopy close softly overhead. As moisture continues to rise, the air above dense forests grows unstable. In large systems like the Amazon, this constant upward flow of warm, wet air helps thunderstorms form almost daily. In this way, forests don't merely wait for storms to arrive, they help summon them. The lightning that flashes overhead is in part born from the forest's own breath, completing a loop where trees release water, clouds build energy, and electricity returns to the land. It is a dramatic reminder that forests are not passive backdrops to weather, but active participants in shaping the sky. Some trees rely on fire to reproduce. For certain species, fire is not an enemy, but an essential partner. Trees like lodgepole pines and some eucalyptus species produce cones sealed with resin. These cones can remain closed for years, even decades, until the intense heat of a wildfire melts them open. Only then do the seeds fall, landing on freshly cleared, nutrient rich soil with little competition. The timing is perfect. Sunlight reaches the ground, ash enriches the earth. A new forest begins exactly where the old one burned. What appears to be destruction is in reality a carefully timed renewal written into the biology of the trees themselves. Forests can recover faster than we expect. After severe fires, floods, or storms, a forest may look devastated. Blackened trunks, fallen branches, silence. But beneath the surface, roots often remain alive. Seeds wait in the soil. Fungi continue their quiet work underground. Within weeks, green shoots can appear. Within years, young trees rise. While full recovery may take decades or centuries, forests are remarkably resilient when given the chance. Their ability to return again and again speaks to a deep evolutionary memory of disturbance and renewal. Some forests migrate over time. Forests do not stay fixed forever. As climates shift, tree species slowly move generation by generation, following temperatures and rainfall patterns they can tolerate. Seeds carried by wind water or animals establish new footholds farther north, higher up mountains, or closer to the poles. Over thousands of years, entire forests can drift across continents. What we see today is only a snapshot in a long, slow migration shaped by ice ages, warming periods, and changing seas. Forests influence the chemistry of the air we breathe. Trees do more than produce oxygen. They also absorb pollutants, trap particles on their leaves, and release organic compounds that interact with sunlight and clouds. Some of these compounds help form aerosols that seed clouds, subtly influencing weather and climate. When forests disappear, air quality often declines and atmospheric balances shift. Every breath we take carries traces of forests, whether nearby or far away. Some forests are built on ancient ruins. Around the world, forests grow over the remains of past civilizations. Stone temples, roads, and cities now lie hidden beneath roots and vines. In places like Central America and Southeast Asia, trees have wrapped themselves around walls, pried apart stone blocks, and reclaimed what humans once built. These forests are both destroyers and preservers, slowly erasing structures while protecting them from complete collapse. They blur the line between nature and history, reminding us that time ultimately favors the living landscape. Forests are quieter than they look, but never empty. Even when no animals are visible and the wind is still, forests hum with subtle activity. Water moves through xylem and soil. Cells divide. Fungi exchange nutrients. Insects crawl unseen. The stillness is not absence, but balance. A complex system operating just below the threshold of our senses. And as night deepens, the forest settles into a different rhythm. Temperatures fall, moisture gathers, sounds soften. The canopy becomes a ceiling of shadow and stars. Somewhere, lightning may be forming above distant trees, or roots may be slowly repairing damage from a past fire or frost. Life continues patient and persistent. You can let these images fade gently now. A forest enduring storms, fire cold, and time itself, breathing out clouds, holding carbon, sharing whispers underground. Let your thoughts slow, like footsteps on soft soil. The forest does not hurry, and neither do you need to. Rest here in the quiet understanding that the world is held together by systems older and calmer than any single moment. Dense, humid forests like the Amazon are especially powerful engines for these storms. Day after day, billions of leaves lift water from the soil and release it into the air. That moisture accumulates, rising higher and higher until towering storm clouds form overhead. The result is one of the most electrically active regions on Earth. On some nights, lightning flickers across the Amazon basin thousands of times, illuminating the clouds in distant, silent flashes. Researchers believe that forests may influence storms in another subtle way. Trees release microscopic particles into the air, natural aerosols that can affect how clouds grow, merge, and release rain. In this sense, forests are not simply struck by lightning from above. They help shape the very conditions that allow storms to ignite. Each bolt that splits the sky can be traced back in part to the quiet labor of leaves, releasing moisture hour after hour, day after day, binding forest and atmosphere into a single living system. Some forests stayed green even during the ice ages. When massive glaciers spread across much of the northern hemisphere, it might seem impossible that forests could survive at all. Yet they did. In sheltered regions, protected by mountains or warmed by ocean currents, pockets of trees endured. These forest refuges remained ice-free while the world around them froze. Within these isolated sanctuaries, trees continued to grow, reproduce, and preserve genetic diversity. When the ice finally retreated, these surviving forests expanded outward, recolonizing vast stretches of land. Modern genetic studies still carry the signature of those ancient refuges, tracing lineages back tens of thousands of years. Without them, many of today's forests would never have returned. They stand as proof that life can persist quietly through even the coldest chapters of Earth's history. There are ancient forests buried beneath Antarctic ice. Today, Antarctica feels like the most lifeless continent on Earth. Endless ice, bitter winds. But this frozen world hides a very different past. More than 200 million years ago, Antarctica lay farther north and supported dense forests filled with towering trees. Fossilized stumps, roots, and trunks now lie entombed beneath layers of rock and ice. Some of these ancient forests thrived under extreme conditions, enduring months of total darkness in winter and continuous sunlight in summer. Scientists drilling deep into Antarctic bedrock have uncovered leaf impressions, fossilized wood, and ancient soils that tell the story of this lost green world. These discoveries remind us that climate is never fixed. Continents drift, temperatures swing, and places that seem eternal can transform completely given enough time. The Amazon River once flowed in the opposite direction. Today, the Amazon carries its vast waters eastward into the Atlantic Ocean. But millions of years ago, the story was reversed. Before the Andes rose, the river flowed west, draining into the Pacific. As tectonic forces lifted the mountains, the river's path was slowly blocked. Water pooled, wetlands formed, pressure built. Eventually, the Amazon reversed course, reshaping the continent. This shift transformed how sediments spread across the land, enriching soils and creating the foundation for one of the most biologically diverse forests on Earth. Floodplains expanded, new habitats formed, species adapted and evolved. The forest we know today was born from this immense geological turning point. A reminder that even rivers like forests are shaped by deep time and unstoppable change. Without that immense shift in the planet's geology, the Amazon rainforest as we know it would never have come into being. The reversal of the river reshaped the land, redistributed nutrients, and opened the door for an explosion of life, unlike anywhere else on Earth. It is a quiet reminder that even the greatest rivers carving continents over millions of years are not permanent. They respond to deeper forces beneath the crust, and when they change direction, entire worlds can be born in their wake. Some forests are so dense with life that rain rarely reaches the ground. In certain rainforests, the canopy above forms a living roof so thick that falling rain is intercepted long before it ever touches the soil. Leaves, branches, and vines trap water high in the air, creating a suspended world of moisture. Here, epiphytes, plants that grow on trees rather than in the ground, flourish, drawing water directly from mist and rainfall caught in the canopy. For many animals, this elevated layer becomes a complete habitat of its own. Small frogs, insects, and birds live their entire lives among branches that hold tiny pools, dripping streams, and pockets of damp soil formed from decaying leaves. Scientists who climb into these upper layers often describe the experience as entering a hidden forest above the forest, an ecosystem floating in the air. Meanwhile, far below the forest floor can remain surprisingly dry even while rain pours overhead. In these places, rain does not simply fall, it lingers suspended, cradled by leaves before it ever descends. Rainforests can generate their own thunderstorms. When thunder rolls across a tropical forest, it is not always the result of distant weather fronts. In regions like the Amazon, the forest itself fuels the storm. Each day, countless trees draw water from the soil and release it into the atmosphere through millions of tiny pores in their leaves. This steady exhalation of moisture builds thick, towering clouds above the canopy. As the day warms, these clouds grow heavier and more unstable. By afternoon, the accumulated vapor often collapses into sudden downpours accompanied by lightning and deep echoing thunder. The rain feeds the forest, and the forest responds by releasing more moisture, sustaining a self reinforcing cycle. On an immense scale, the Amazon lifts billions of tons of water into the air each year, enough to maintain its own weather system. In this way, the rainforest is not merely shaped by climate, it helps create it, calling storms into existence through the quiet work of leaves and roots. Forests can even create their own winds. We often think of wind as something born over oceans or driven by distant pressure systems, but large forests can shape air movement locally and regionally. As sunlight warms the canopy, the air above it heats and rises. Cooler air from surrounding areas flows inward to replace it, setting gentle breezes in motion. Within vast forests, these subtle currents can combine, influencing weather patterns across entire regions. Leaves themselves contribute to this process. Their uneven surfaces slow moving air, creating turbulence that stirs and mixes the atmosphere near the ground. The forest becomes an active landscape of motion, guiding air through trunks and branches, rather than simply standing beneath it. If you pause in a forest clearing, you may feel it, a soft movement of that seems to rise from the trees themselves, a breath born not of distant storms, but of living wood and leaf. Tropical forests release vast rivers of water vapor into the sky. Forests breathe water as surely as they breathe air. Through the constant process of transpiration, trees lift water from deep within the soil and release it upward molecule by molecule. In tropical forests, this invisible flow forms immense atmospheric rivers, streams of moisture moving through the sky. These airborne rivers travel far beyond the forest that created them, carrying rain to distant lands. Moisture released in the Amazon can fall days later as rain thousands of kilometers away, nourishing fields, rivers, and cities far beyond South America. The forest, in this sense, is not confined to its borders. Its breath travels the planet, stitching distant regions together through shared water and air. As you rest with this thought, imagine the slow, steady exchange unfolding above and below the canopy. Water rising from roots, drifting through leaves, forming clouds and returning again as rain. A cycle older than humanity, patient and precise. Forests do not rush. They inhale, they exhale, and in that quiet rhythm they shape the world. Forests help keep the poles frozen. At first, it might seem strange that trees thousands of kilometers away could influence ice at the top of the world. But forests play a powerful role in regulating Earth's temperature. By absorbing carbon dioxide, they slow the warming of the atmosphere, which in turn helps preserve polar ice. Forests also affect wind patterns and cloud formation, influencing how heat moves around the planet. When large forested regions are lost, more heat is trapped, and that warmth eventually reaches the poles, accelerating ice melt. In this way, forests act like distant guardians of the Arctic and Antarctic. Their roots in warm soil help hold the cold in place, far away, linking tropical canopies to frozen horizons in a single climate system. Some forests have soils deeper than skyscrapers are tall. Beneath many forests lies a world just as complex as the one above. Forest soils can extend tens of meters downward, built slowly over thousands of years from fallen leaves, roots, and decaying life. In tropical rainforests, this underground layer stores enormous amounts of nutrients and carbon. In boreal forests, thick blankets of moss and peat insulate the ground, locking away organic matter in cold, oxygen poor conditions. These deep soils are living archives holding the chemical memory of past climates, fires, and floods. To stand on a forest floor is to stand atop centuries of quiet accumulation, a hidden foundation that supports everything above it. Trees can influence where rivers flow. Forests don't just grow beside rivers, they help shape them. Tree roots stabilize soil, slowing erosion and guiding how water moves across the land. In forested regions, rainfall is absorbed, gradually released into streams and rivers over time. This steady flow reduces floods and sustains rivers during dry seasons. When forests are removed, rain rushes across bare ground, carving new channels, washing soil away, and altering entire watersheds. Over long periods, forests quietly decide where water lingers, where it flows, and where rivers are born. Some forests are older than the mountains around them. While mountains rise and erode over millions of years, certain forest ecosystems have persisted through astonishing spans of time. In parts of Australia, ancient forests trace their lineage back more than 100 million years, surviving continental drift and climate shifts. These forests adapted as landscapes changed beneath them, moving, shrinking, and expanding without disappearing. They are living relics of worlds long gone, carrying genetic memories from eras when dinosaurs still walked beneath their canopies. Forests can slow the spread of deserts. At the edges of drylands, forests act as natural barriers against desert expansion. Tree cover helps retain moisture, anchor soil, and cool the air. In places where forests are cleared, deserts can advance rapidly, carried by wind and erosion. In contrast, reforestation projects have shown that planting trees can stabilize land, restore rainfall patterns, and even push deserts back. A line of trees can become a quiet frontier between fertility and dust. The sound of a forest changes with its health. Healthy forests have a signature soundscape. Birds call from multiple layers, insects hum, leaves rustle, and the air feels alive with motion. As forests degrade, these sounds fade. Fewer species mean quieter canopies, longer silences, and a loss that can be heard before it is fully seen. Scientists now study forest soundscapes to measure biodiversity using microphones to listen for the subtle shifts that signal change. In this way, forests speak not only through growth, but through sound. Some forests exist entirely in the clouds. Cloud forests live at elevations where mist drifts through the trees for much of the year. These forests rely more on fog than rain. Leaves, branches, and moss capture tiny droplets from passing clouds, funneling water downward. Many species found here exist nowhere else on Earth, adapted to constant moisture and cool air. These forests are fragile. A slight rise in temperature can lift cloud layers higher, leaving the trees dry and vulnerable. To lose a cloud forest is to lose an ecosystem balanced on the edge of the sky. Forests remember past climates in their rings. Each year, a tree lays down a new ring of growth. Wide rings tell stories of warm, wet years. Narrow rings record drought, cold, or hardship. By studying these rings, scientists can reconstruct climate histories stretching back thousands of years. Trees become timekeepers, preserving records of volcanic eruptions, ancient storms, and long forgotten dry spells. Long after human records fade, forests continue to remember. And as you rest now, you might imagine these forests quietly at work, leaves lifting water into the air, roots holding soil in place, rings forming slowly beneath bark. Across the planet, forests are breathing, cooling, stabilizing, and remembering. They do not rush, they do not shout, they simply continue. And in their patience, there is something deeply calming, something that reminds us that even in a changing world, some rhythms remain slow, steady, and kind. It may seem unusual to connect warm, tropical forests with the frozen edges of the planet, yet Earth's systems are tightly woven together. Moisture and heat released from vast forest canopies rise into the atmosphere and help steer large-scale circulation patterns that span entire hemispheres. These invisible currents influence how warmth is distributed across the globe and ultimately how stable polar ice remains. Forests also lock away immense quantities of carbon, keeping greenhouse gases from accumulating in the air. Without this quiet service, temperatures at the poles would climb far more quickly, accelerating the melting of ice sheets and glaciers. Even forests closer to the Arctic play a direct role insulating permafrost and shading snow so it reflects sunlight rather than absorbing heat. In this way, the future of the frozen poles is inseparable from the health of the world's forests. What happens in green equatorial belts sends ripples outward to the coldest margins of the earth. To protect forests is, in a very real sense, to protect ice oceans and coastlines everywhere. The planet functions as a web. Pull one thread, and even the most distant regions can feel the strain. Forests also help shape the winds that circle the globe. They do not simply exist beneath the atmosphere, they interact with it constantly. As forests release vast amounts of water vapor into the air, they create subtle pressure differences that help draw moist air inland from the oceans. Scientists refer to this process as the biotic pump. Without it, many interior regions of continents might become far drier, even desert-like. Research suggests that forests influence air circulation not only on a local scale, but across continents, nudging storm tracks, guiding winds, and shaping where rain ultimately falls. The gentle movement of air through leaves in one region can influence weather patterns thousands of kilometers away. Winds that nourish crops or steer storms across seas may owe part of their journey to the steady breathing of forests. In this sense, forests are not passive passengers beneath the sky. They are active participants, quietly guiding the flow of air that wraps around the planet. Some trees release chemicals that gently alter human moods. If you have ever felt calmer while walking beneath tall trees, the sensation may be more than imagination. Many trees emit airborne compounds known as phytoncides, natural chemicals that help protect them from insects and disease. When humans inhale these compounds, studies show measurable effects. Stress hormones can decrease heart rate, may slow, and immune activity can increase. This is one reason the practice of forest bathing, first formalized in Japan, is now recommended as a form of preventative health care. Breathing in the subtle scents of pine cedar or cypress does more than please the senses. It quietly changes body chemistry. Forest air is not only rich in oxygen, it carries invisible signals that interact with our nervous system. Trees defending themselves end up calming us. The exchange hints at how deeply human biology remains connected to natural environments, reminding us that forests are not just scenery to be admired, but silent companions shaping our inner balance. Forest sounds have a measurable effect on the human nervous system. When you step into a forest and allow yourself to listen, sound becomes the dominant sense. Leaves whispering in the wind, distant bird calls the steady rhythm of insects, water dripping softly from branches. Studies show that these natural sound patterns can significantly reduce cortisol, the body's main stress hormone. Unlike the sharp, irregular noises of traffic or machinery, forest sounds are layered, predictable, and gently rhythmic. The brain interprets them as signals of safety. Heart rate slows, breathing deepens, the nervous system shifts out of alert mode and into rest. Some hospitals now use forest sound recordings to support healing and recovery, while city planners explore how natural soundscapes might soften urban environments. Yet recordings can only go so far. The living chorus of a real forest surrounds you completely. Listening feels like a mental reset, a quiet return to balance, reminding us that calm does not require silence, only the right kind of sound. Forests can subtly change the color of the air itself. On warm summer days, when you look across vast stretches of woodland, you may notice a soft blue haze resting over distant hills. This is not just moisture or distance playing tricks on the eye. Trees, especially conifers, release organic compounds into the air that scatter sunlight in specific ways. As light passes through these particles, shorter blue wavelengths spread more easily, tinting the atmosphere with a gentle bluish glow. This effect is so strong in some regions that entire mountain ranges have been named for it, like the Blue Ridge Mountains. What you see is the chemistry of forests interacting with light leaves, shaping the sky as much as rock and cloud. Forests do not only occupy the land, they influence how the air looks, how light travels, and how landscapes are perceived. Every misty horizon carries the imprint of countless trees breathing invisibly into the atmosphere. The night sky above forests is never truly dark. After sunset, a forest can feel completely wrapped in shadow, yet high above the canopy, the atmosphere itself emits faint energy known as air glow. This phenomenon comes from chemical reactions in the upper layers of the atmosphere as molecules release stored energy. In regions far from artificial light, especially above large forests, this glow becomes more apparent to sensitive instruments. Some nocturnal animals and insects may even perceive parts of this faint radiation, using it as subtle guidance through the night. To human eyes, the darkness feels complete, but above the sky hums softly with invisible light, a reminder that even at night, Energy continues to flow overhead, unseen, yet constant, adding quiet depth to the forest's nighttime presence. Forest air carries countless microscopic travelers. Every breath taken beneath trees contains far more than oxygen alone. Forest air is filled with tiny particles released by leaves, bark soil, and fungi, microscopic droplets of water vapor, fragments of organic compounds, pollen grains, spores drifting gently between branches. These particles help shape cloud formation, influence rainfall, and even interact with human immune systems. Inhaling forest air is like breathing in a living mixture of the ecosystem itself, invisible, complex, and constantly changing. What feels fresh and clean is also biologically rich, a reminder that forests are not the empty spaces between trees, but dense, active environments that surround us down to the smallest scale. Each breath connects your body to the silent processes unfolding all around. In some forests, insects may rival leaves in sheer numbers. At first glance, a forest seems defined by trees and foliage layers of green stretching upward toward the light. But look closer, and another world reveals itself. In many tropical forests, insects outnumber leaves by astonishing margins. Ant colonies alone can contain millions of individuals moving in coordinated rivers across the ground and up tree trunks. Termites hollow out wood and soil recycling dead material into nutrients. Beetles, flies, moths, and countless other species occupy every available niche, from the canopy to the deepest layers of leaf litter. Together they form the engine that keeps the forest running, breaking down organic matter, pollinating plants, and feeding birds, reptiles, and mammals. Those small and often overlooked insects are the forest's most numerous workers, shaping its structure through constant, tireless motion. Many forest insects act as living architects. Some insects do more than simply inhabit the forest. They actively reshape it. Leafcutter ants, for example, harvest vast quantities of leaves, not to eat directly, but to cultivate underground fungus gardens that feed their colonies. Termites alter soil chemistry and water flow with their mounds, creating microhabitats that benefit other plants and animals. Even tiny beetles tunneling beneath bark help regulate tree populations by targeting weakened individuals. Over time, these small actions accumulate into large effects. Forests grow regenerate and evolve partly under the guidance of creatures no bigger than a fingernail. Their influence is quiet but profound, reminding us that size has little to do with impact in the natural world. Forests operate on layers of time, moving at different speeds. Above ground, leaves flutter, birds move, insects buzz. Below, roots grow slowly, fungi spread inch by inch, and soil microbes work at a pace measured in years or decades. At the same time, ancient trees record centuries in their rings, while entire forests shift and migrate over thousands of years. All these timelines coexist in the same place. A moment in a forest contains processes unfolding over seconds, seasons, and millennia at once. To stand still among the trees is to stand inside overlapping clocks, each ticking at its own rhythm. The forest feels calm because nothing is rushed. Everything moves at the speed it needs to survive. Forests remember the past in their structure. Every forest carries the imprint of what came before. Fire scars etched into bark uneven tree ages, marking old storms' soil layers, recording floods and droughts. Even the arrangement of species reflects ancient events. Glaciers retreating rivers, shifting climates changing. Trees growing today are responding to conditions shaped long before humans arrived. In this way, forests function as living archives storing history not in words, but in growth patterns, chemical traces, and genetic memory. Walking through a forest is like reading a book written slowly over thousands of years, one that continues to add new pages with each passing season. As night deepens, the forest never truly sleeps. When darkness settles, activity simply changes form. Nocturnal insects emerge, mammals move quietly through shadows. Fungi continue breaking down fallen wood. Roots exchange nutrients, soil microbes carry on their invisible labor. Even without sunlight, the forest remains fully alive, humming with processes that do not depend on day. This constant low level activity creates a sense of continuity, a reassurance that life does not stop when light fades. It merely shifts into another mode, softer and slower, but no less essential. And as you rest, you are not separate from this rhythm. Your breathing slows, your thoughts drift, and your body responds to the same patterns of rest and renewal found throughout the forest. Just as trees release and reclaim carbon, just as soil breathes and settles, your nervous system eases into stillness. The forest does not demand attention. It simply exists, offering its steady pace as an invitation to let go. Here, nothing needs to be forced. Everything knows when to slow, when to pause, and when to begin again. In a single hectare of rainforest, scientists estimate there may be more than 40,000 species of insects, with uncountable individuals occupying every layer of life. Many have never been described, let alone named. They hide beneath bark, within leaves, inside soil, and in the air itself. This vast abundance is not incidental. Insects pollinate flowers, break down fallen wood, recycle nutrients, and feed birds, reptiles, and mammals. Without them, the forest would slowly come apart, piece by piece. Their presence is the quiet current beneath everything else, more numerous than leaves moving constantly, yet mostly unseen, holding the entire system together through sheer persistence. Some forest plants have turned the tables and learned to feed on insects. In nutrient poor soils, where competition is fierce, certain plants have evolved a very different strategy. Carnivorous species, such as pitcher plants and sundews, lure insects with sweet scents, vivid colors, or glistening surfaces that resemble drops of nectar. Once an insect is trapped, enzymes slowly dissolve it, allowing the plant to absorb nitrogen and minerals that the soil cannot provide. In some tropical forests, these plants grow so large that they can capture not only insects, but frogs and small mammals as well. These adaptations are not acts of aggression, but survival. In the deep shade of the understory, where sunlight is scarce and nutrients are limited, evolution finds unusual solutions. Even here, among still leaves and filtered light, the forest hosts quiet dramas, of pursuit and adaptation. Forests also shelter invisible worlds that science has only begun to uncover. Within forest soil, fresh water, insects, animals, and even plants themselves live vast communities of viruses. Most of these have never been identified. Many do not cause illness at all, but instead help regulate populations of microbes, subtly shaping ecological balance. Some viruses may one day provide insights for medicine or biotechnology carrying genetic tools refined over millions of years. Forests are not only reservoirs of visible life, but libraries of hidden information written in DNA too small to see. Beneath every root and leaf, unseen interactions are unfolding, quietly influencing the health and resilience of the ecosystem. High above the rainforest canopy forms a world of its own. In dense tropical forests, the uppermost layer of branches and leaves can become so tightly woven that less than 1% of sunlight reaches the ground below. This canopy functions like a living roof, intercepting rain, slowing falling objects, and creating a humid world suspended above the forest floor. In some places, water never reaches the soil directly. It is caught, stored, and redistributed among leaves, mosses, and epiphytes that live their entire lives without touching the ground. Scientists who climb into this upper realm often describe it as a separate continent filled with its own streams, pools, insects, and plants. Below the forest floor remains dim and quiet, while above life unfolds in constant motion. The forest layer by layer reveals itself as not one ecosystem, but many stacked together. From the invisible life in the soil to the dense canopy overhead, each level supports the next, bound together by flows of energy, water, and time. Nothing exists alone. Every insect, plant, and microbe is part of a continuous exchange that keeps the forest breathing, growing, and adapting. And as you listen, letting your thoughts slow, you may sense it. The steady presence of a system that has learned over millions of years how to endure through balance rather than force. This leafy shield above does more than block light. It creates a sheltered world beneath it, cooler and more humid than the air above the treetops. For countless species, the canopy is not a roof, but a homeland. Many animals and plants spend their entire lives suspended in branches, never touching the soil below. For them, the forest exists sideways and upward, shaped by vines that flow like rivers, platforms of wood that serve as resting grounds, and walls made entirely of living green architecture. High above the ground, entire miniature worlds unfold. Mosses blanket branches, orchids bloom without soil, and bromeliads gather rainwater in their cupped leaves. These small reservoirs become homes for frogs, insects, and even tiny aquatic creatures. Ant colonies carve passageways through wood, while birds and monkeys travel through the treetops as effortlessly as fish through water. Scientists who enter this realm often describe a feeling of discovery, as if they have stepped into a parallel ecosystem floating above the earth. The canopy expands the forest upward, effectively doubling its living space and stacking habitats layer upon layer. For most of human history, this aerial world remained unseen. Only in recent decades have researchers begun to study it closely, revealing one of the most biologically rich environments on the planet. The canopy reminds us that forests are not just landscapes spread across the ground. They are vertical worlds rising into the sky, carrying as much life above the soil as below it. In many rainforests, the greatest concentration of life is not found at ground level at all. The canopy often hosts more species than the forest floor. Insects, birds, reptiles, and mammals crowd the upper branches where food is abundant and sunlight is strongest. Entire plant species live exclusively in this layer, anchoring themselves to bark rather than earth. Scientists believe that more than half of all rainforest species may exist only in the canopy, rarely descending, if ever. Each small patch of treetops can hold an astonishing variety of life, sometimes more than an open meadow or grassland many times its size. For those who dwell there, the canopy is not a ceiling, but a vast city in the sky full of movement, sound, and opportunity. The forest floor below becomes just another distant level, quiet and dim, rarely visited. Down beneath this living roof, sunlight grows scarce. In dense tropical forests, only a thin fraction of light filters through the leaves, sometimes less than 1% of what falls above. The forest floor exists in a world of shadow and soft green glow. Plants that live here have adapted to these conditions, growing broad, thin leaves designed to catch every stray ray. Growth is slow, deliberate, and careful, shaped by patience rather than abundance. Life on the forest floor moves at a different rhythm. Energy arrives in fragments. Light comes in brief flashes when a branch falls or a gap opens overhead. And in those moments, new plants surge upward, racing toward the sky before the canopy closes once again. Vines wrap around stone walls. Roots grow through stairways. Entire temples and settlements disappear beneath layers of leaves and soil. Forests have a way of reclaiming what humans leave behind, not violently, but patiently. Over decades and centuries, structures soften, crumble, and become part of the living system once more. What looks like untouched wilderness is often layered with forgotten stories beneath it. In many cases, these ancient sites were carefully designed to work with the forest rather than against it. Water channels followed natural slopes. Crops grew among trees. Cities breathed with the landscape instead of replacing it. When the forest returned, it did not erase these places completely. It preserved them hidden, waiting for the right moment to be seen again. Forests in this way are not just natural archives, but historical ones, quietly holding memories of civilizations long gone. Some forests grow on land that never fully dries. In wetlands and floodplain forests, water is a constant presence. Trees there have adapted to survive with roots submerged for months at a time. Some grow hollow trunks that channel oxygen down to their roots. Others rise on stilts, lifting themselves above the waterline. These forests blur the boundary between land and water, creating environments where fish swim among tree trunks and birds nest above mirrored reflections. Seasonally flooded forests are among the most productive ecosystems on Earth. Nutrients carried by floodwaters replenish the soil again and again, fueling explosive growth. When the waters retreat, the forest breathes out life in abundance. Seeds sprout, insects multiply, and animals gather to feed. The rhythm of flooding and drying becomes the forest's pulse, steady and dependable. Some trees flower only once in their lifetime. In certain forest species, growth is slow and patient, building toward a single moment. These trees may spend decades gathering energy before producing flowers just once. When they bloom, it can be spectacular. Massive clusters of blossoms appear almost overnight, filling the air with scent and drawing pollinators from miles away. Soon after the tree dies, having passed its energy forward into seeds. This strategy may seem extreme, but it is surprisingly effective. By flowering all at once, these trees overwhelm predators and ensure that at least some seeds survive. The forest floor becomes carpeted with new life, continuing the cycle. In forests, even endings are carefully timed beginnings. Some forest animals shape the landscape itself. Elephants push over trees, creating clearings that allow sunlight to reach the ground. Beavers fell trunks to build dams, flooding forests and creating wetlands. Even small creatures like ants and termites move enormous amounts of soil over time, reshaping drainage and nutrient flow. These animals are not just inhabitants of forests, they are engineers. Through their daily actions, they influence which plants grow, where water flows, and how the forest regenerates. Without them, forests would look very different. Life here is not passive. It constantly molds and remakes the world around it. As the forest grows darker and quieter, everything slows. Light fades, movement softens, the forest settles into its own rhythm, one shaped by patience rather than speed. Nothing is rushed, nothing is wasted, and in that stillness, the forest continues its work. Breathing, remembering, growing in these forests, the tree itself becomes a bridge between worlds. The trunk connects soil and canopy, earth and air, animals that climb and those that cannot. What seems unusual to us is simply efficiency shaped by evolution. The forest rewards any form that finds balance within its crowded vertical space. Some forests experience rain almost every day. In certain tropical regions, rainforests receive rainfall on most days of the year. These are not always violent storms. Often, the rain arrives gently as mist or light showers that drift through the leaves. The constant moisture feeds an unbroken cycle of growth. Fallen leaves decompose rapidly. New plants rise quickly to take their place. Nothing stays bare for long. This near daily rain also washes nutrients through the forest, redistributing life again and again. It keeps temperatures stable and humidity high, allowing species to thrive that could not survive elsewhere. To walk through such a forest is to feel wrapped in softness, damp air, muted sounds, the steady whisper of water returning to the earth. Some trees shed entire branches to survive. In dense forests, light is precious and storms are frequent. Some trees have evolved an unusual strategy. Instead of risking their whole structure, they shed large branches when stressed. During high winds or drought, these limbs detach and fall away, reducing strain on the trunk. On the forest floor, the fallen branches become resources. Insects colonize them. Fungi spread through the wood. Nutrients return to the soil, What looks like loss is actually protection and renewal. The tree survives by letting go, and the forest transforms that loss into life. Forest trees can synchronize their flowering. In some forests, entire populations of trees bloom at the same time, sometimes after years of silence. This phenomenon, known as massed flowering, overwhelms pollinators and seed predators alike. So many flowers or seeds appear at once that predators cannot consume them all. The result is regeneration on a massive scale. Seedlings carpet the ground. The forest renews itself in waves rather than drips. These synchronized events are triggered by subtle cues, temperature shifts, rainfall patterns, even long term climate rhythms. The forest moves together, not as individuals, but as a collective organism responding to time itself. Some forests are older than written language. Long before humans recorded history, forests rose, fell, and rose again. Some ecosystems have existed in roughly the same place for millions of years. While individual trees come and go, the forest itself persists, adapting slowly as climates shift and continents move. These ancient forests have seen ice ages, volcanic eruptions, and the rise of countless species. Their soils carry memory in layers. Their genetic diversity reflects survival across deep time. To walk among them is to step into a living continuity that stretches far beyond human lifespans. Forests can heal damaged land. When forests return to areas stripped by mining, farming, or fire, they begin a slow process of repair. Roots stabilize soil, leaves soften rainfall, microbes rebuild fertility grain by grain. Over decades, damaged ground becomes capable of holding life again. This healing is not instant, but it is persistent. Forests do not rush. They work quietly, steadily, restoring balance through countless small actions. In this way, forests are among Earth's greatest healers, mending wounds we once thought permanent. And as the forest continues its slow work, the air grows softer, sounds dim, movements settle. The forest does not hurry toward night, it simply allows it to arrive. If you're feeling the quiet deepen now, that's natural. The forest invites rest. It has always known how to wait. Some forest trees drink from deep underground rivers. While many trees rely on surface rain, others reach far deeper. In ancient forests, certain species send roots tens of meters down into the earth, tapping underground aquifers and hidden water tables. These deep roots allow trees to survive droughts that would kill most vegetation. During dry seasons, these trees can continue releasing moisture into the air, helping stabilize the forest's climate when rain disappears. In some cases, they even share this water indirectly with neighboring plants through root networks and soil moisture. A single, deep rooted tree can act like a quiet well for the forest around it, drawing life upward from darkness below. Forests recycle nearly everything they produce. In a healthy forest, waste is almost non existent. Fallen leaves, dead insects, broken branches, and animal remains are quickly absorbed back into the system. Fungi, bacteria, insects, and worms break organic matter down into nutrients that feed new growth. Nothing lingers for long. What falls becomes food. What decays becomes soil. This constant recycling allows forests to thrive even in nutrient poor environments. The forest floor may look messy, but it is incredibly efficient. Every fragment has a purpose. Every ending feeds a beginning. Some forests grow on soils that are almost barren. It may seem surprising, but many of the world's lushest forests grow on soils that are naturally poor in nutrients. Tropical rainforest soils are often thin and heavily leached by rain. The richness of the forest comes not from the ground, but from the rapid recycling above it. Nutrients are held tightly in living plants, leaves, and roots. The moment something falls, it is reused. This delicate balance means that when forests are cleared, the fertility quickly disappears. Without the living system, the soil alone cannot sustain life for long. The forest is not fed by the land. The forest is the system that feeds itself. Forests slow down time. Inside a forest, time feels different. Light shifts slowly. Sounds soften. Movement becomes measured. Studies show that people walking through forests experience a slower perception of time as heart rates drop and attention widens. The forest does not rush. Trees grow in decades. Soil forms in centuries. Ecosystems mature over millennia. To step into a forest is to step out of urgency and into patience. It is an environment shaped not by speed, but by persistence. Some forests are shaped by animals as much as trees. Forests are not built by plants alone. Animals shape them constantly. Elephants knock down trees, opening clearings that allow sunlight to reach the ground. Birds spread seeds across vast distances. Rodents bury nuts that grow into new trees. Insects pollinate, prune, and fertilize. Remove the animals and the forest changes. Diversity shrinks. Growth slows. The forest is a collaboration between roots, wings, teeth, and claws. Every species plays a role in shaping the structure of the trees themselves. Forests remember disturbance for centuries. A forest never forgets what has happened to it. Fires, storms, droughts, and human activity leave signatures that can persist for hundreds of years. Tree rings record years of hardship and abundance. Soil layers preserve traces of ash and erosion. Species composition shifts in lasting ways. Even after a forest appears healed, its past lives on in subtle patterns. The forest carries memory not in thought, but in structure. Every path of regrowth tells a story of what came before, and as these stories layer quietly upon one another, the forest continues, breathing, recycling, holding water, holding time. If your thoughts feel slower, now that's all right. Forests are patient teachers. Each forest then edits the rain in its own quiet way, shaping the water that nourishes it. Some forests filter water as effectively as treatment plants. As rain moves through leaves, roots and layers of soil forests act as natural filters. Sediment is trapped. Pollutants are broken down by microbes. Excess nutrients are absorbed by roots and fungi. By the time the water reaches streams and aquifers, it is often far cleaner than when it fell from the sky. This is why many of the world's major cities rely on forested watersheds for drinking water. New York City, for example, protects vast forest areas rather than building massive filtration systems. The forest does the work quietly, continuously, without machinery or noise. Every root becomes part of a purification system older than civilization itself. Forests slow floods and soften storms. When heavy rain falls on bare land, water rushes away, carving channels and flooding rivers. In forests, that same rain is intercepted by leaves, absorbed by soil, and guided gently downward through roots and moss. This slows runoff dramatically. During storms, forests act like giant sponges, reducing flood peaks and protecting communities downstream. Even days after rain has stopped, forests continue releasing stored water, slowly feeding rivers during dry periods. In this way, forests smooth the extremes, softening both deluge and drought. They turn chaos into rhythm. Some forests create mist that never reaches the ground. In dense, humid forests, water doesn't always fall as rain. Sometimes it condenses directly on leaves as fog or mist. This process, known as fog interception, allows trees to harvest water straight from the air. Cloud forests depend on this invisible rain. Moisture drifts through the canopy beads on mosses and leaves and drips quietly into the soil. Even during dry seasons, these forests remain lush, sustained by clouds that touch the land. The forest does not wait for rain, it gathers it. Forests can influence rainfall thousands of miles away. The water vapor released by forests does not simply fall back nearby. Carried by winds, it travels across continents. Moisture from the Amazon helps generate rain as far away as the Andes, the Caribbean, and parts of North America. This means when a forest breathes distant lands, listen. Crops, rivers, and cities far from the trees depend on this invisible exchange. Remove the forest and rainfall patterns can shift sometimes permanently. The forest's reach extends far beyond its borders, written in clouds and storms far from where the leaves grow. Forests store water in living memory. Trees remember water. Their growth rings record wet years and dry ones. Their roots expand or retreat based on past conditions. Forest soils built slowly over centuries hold moisture long after rain has passed. In drought-prone regions, forests with deep soils and old growth act as archives of water history. They buffer extremes, not just season to season, but generation to generation. The forest carries the memory of Wowland forward, protecting future life with lessons learned in silence. And so forests are not only green places, they are reservoirs, filters, buffers, messengers. They hold water the way they hold time, patiently, quietly, for everyone downstream. If your breathing feels slow, now let it stay that way. Like water moving through roots, there is no need to hurry. Forests influence the migration of global bird populations. For countless bird species, forests are not just destinations, but vital landmarks along epic journeys that span continents. Migratory birds rely on forests as stopover sites where they can rest, feed, and recover energy before continuing on. A single stretch of forest can determine whether a bird survives the next leg of its flight. The timing of leaf growth, flowering, and insect hatches in forests acts like a living calendar. Birds arrive when food is abundant, guided by instinct and subtle environmental cues. If forests disappear or their rhythms shift. These ancient routes can break. Entire migrations may fail, not because the birds forgot the way, but because the forest they depended on is no longer there. In this way, forests quietly choreograph movements across the sky, linking distant countries through wings and memory. Some forests act as sound highways for animals. Sound travels differently in a forest than in open land. Trunks, leaves, and humidity bend and carry noise in complex ways. Low frequency sounds like the calls of elephants or howler monkeys can travel for kilometers through dense forest rolling between trees like distant thunder. Many animals have evolved calls tuned precisely to these conditions. Birds sing at frequencies that slip between leaves. Frogs call at pitches that cut through moisture heavy air. For them, the forest is not silent, but acoustically engineered. Every call, reply, and echo moves along invisible corridors shaped by wood and air. Communication in forests is not just about voices, but about architecture made of living trees. Forests can preserve sound and living memory. Some tree rings record more than age and climate. Scientists have discovered that extreme events, volcanic eruptions, fires, even intense storms, can leave chemical or structural signatures inside wood. In this sense, forests remember not just seasons, but catastrophes. A tree standing today may carry within it evidence of events humans never witnessed. Long after sound waves faded and skies cleared, the forest kept a record. Each trunk becomes an archive, storing whispers of the past in layers of growth. Time is written in wood, year by year, quietly waiting to be read. Forests influence how clouds form at night. When the sun sets, forests do not fall asleep. As temperatures drop, moisture released during the day condenses near the canopy. This can lead to low-lying clouds or fog forming directly above forests while nearby open land remains clear. These nighttime clouds can reduce heat loss, keeping forests warmer than surrounding areas. They also feed moisture back into leaves and soil before morning arrives. The forest, in effect, wraps itself in a blanket of cloud, recycling its own breath through the dark hours. Some forests create their own internal rain cycles. In extremely dense rainforests, water can cycle multiple times before ever reaching a river. Rain falls onto leaves, evaporates, condenses, and falls again within the forest itself. This looping journey may repeat several times in a single day. To the forest, rain is not a one-way event. It is a conversation between leaf, air, and soil. Water rarely leaves in a hurry. It lingers, moves slowly, and participates in the forest's internal rhythm. This self-contained cycle is one reason rainforests remain so stable even when conditions outside begin to change. Forests shape how long snow stays on the ground. In colder regions, forests determine the fate of snow. Tree canopies intercept snowfall, allowing it to sublimate directly into the air instead of piling on the ground. At the same time, shade slows melting, keeping snow intact longer into spring. This balance controls when water is released into streams and rivers. Too fast, and floods follow. Too slow, and ecosystems dry out. Forests act as moderators, releasing meltwater, gradually guiding the transition from winter to spring with remarkable precision. Old forests stabilize landscapes for centuries. The roots of mature forests bind soil deep underground. On slopes, this prevents landslides. Along rivers, it reduces erosion. Even during storms and earthquakes, ancient forests can hold land together when bare ground would fail. This stability builds over centuries. Each generation of trees strengthens what the last began. When old forests are removed, the land often responds quickly with floods, collapses, and loss of fertile soil. What took hundreds of years to weave together can unravel in a single season. Forests slow time, not in the physical sense, but in how they are experienced. Growth is measured in decades. Recovery unfolds over lifetimes. Events that feel urgent elsewhere become gentle here, stretched across rings and roots. To walk in a forest is to step into a different pace of existence, one where patience is rewarded, where nothing rushes, where even change arrives quietly. And as you rest now, you might imagine that pace settling into you. Breath slow as sap, thoughts drifting like mist between trees. The forest continues its work, whether we are awake or asleep, holding water, shaping air, remembering time. You don't need to follow it, just let it be there. When the hive is reached and humans harvest the honey, they leave behind wax and larvae that the bird feeds on. It is a rare example of mutual communication between wild animals and people passed down through generations on both sides. The honey guide understands human behavior, and humans learn to read the bird's calls and movements. Deep in the forest, this quiet cooperation turns survival into partnership, reminding us that forests have long been places where human and non-human lives learn to listen to one another. Some forests are shaped by termites as much as by trees. In tropical and subtropical forests, termites are among the most influential architects of the land. Their towering mounds alter soil chemistry, improve drainage, and concentrate nutrients in ways that benefit surrounding plants. The soil taken from deep underground is rich in minerals, and when termites bring it to the surface, it creates fertile islands where trees grow faster and stronger. These termite-built landscapes can be so influential that satellite images reveal vegetation patterns tracing the outlines of underground colonies. Though often unseen, termites quietly engineer forests from below, proving that even the smallest creatures can shape ecosystems on vast scales. Forest trees can synchronize their flowering across miles. In some forests, entire populations of trees flower at the same time, sometimes after years of silence. This phenomenon, known as massed flowering, floods the forest with blossoms, pollen, or seeds all at once. The strategy overwhelms predators, ensuring that at least some seeds survive to grow. The synchronization can span hundreds of kilometers, suggesting that trees respond to shared environmental signals such as temperature shifts or rainfall patterns. When it happens, the forest transforms overnight. Canopies erupt in color, insects swarm, and animals gather to feast. It is a reminder that forests can act not just as collections of individuals, but as coordinated living systems moving in unison. Some forests hum with electricity during storms, As thunderstorms pass over forests, electric fields can build up around treetops. Leaves and branches interact with charged air, sometimes creating faint crackling sounds or subtle shifts in ion concentrations. Some scientists believe plants may even sense approaching storms through these electrical changes, adjusting their physiology before rain arrives. To animals sensitive to electrical fields, a forest during a storm may feel alive with invisible energy. The air thickens, the canopy tingles. Nature signals what is coming long before the first drop falls. Forests can recover from devastation in unexpected ways. After volcanic eruptions, landslides, or massive fires, forests often return faster than expected. Seeds buried deep in soil survive heat and ash. Roots sprout new shoots from what appears to be dead ground. Wind and animals carry life back into empty spaces. What looks like destruction is often transformation. Pioneer species arrive first, followed by shrubs, then trees. Over decades, a mature forest may re-emerge different in composition, but alive again. Resilience is written into forest time, measured not in days, but in generations. Some forests never truly sleep. Even at night, forests are busy. Roots continue to grow. Fungi trade nutrients underground. Nocturnal animals emerge to hunt and forage. Trees subtly adjust water pressure in their tissues, responding to cooler air and rising humidity. The forest after dark is not a quieter version of day, but a different world entirely. One ruled by scent instead of sight, vibration instead of color. Life simply changes, shift, continuing its work under stars and clouded moons. And as this journey through forests begins to slow, you might imagine standing still beneath tall trees, air cool against your skin, leaves stirring far above, soil steady underfoot. Forests do not rush, they wait, they endure, they breathe in cycles older than memory. If your thoughts are drifting now, you can let them wander between trunks and shadows. The forest will keep going, growing, listening, and when you are ready to rest, it will still be there. Over time, trees take hold on these drifting platforms, their roots tangled together like woven rope. The forest is no longer anchored to solid ground, but to a living raft that rises and falls with the water. In places like the Amazon floodplains and parts of Southeast Asia, these floating forests can shift slowly across rivers and lakes, changing position with the seasons. For animals, they become moving habitats. Birds nest in them, insects swarm across them, and fish shelter beneath their shaded undersides. To stand on one feels unsettling, the ground gently yielding beneath your feet, reminding you that even forests can learn to float. It is a vision of nature refusing to be fixed, adapting even the idea of land itself. Some forests experience seasons without leaves ever falling. In tropical forests near the equator, the familiar cycle of autumn simply doesn't exist. Trees do shed their leaves, but not all at once. Instead, leaves are replaced gradually throughout the year. At any moment, some are falling, others are growing, and many are fully mature. This constant renewal keeps the forest green year-round. There is no single season of decline, only continuous transition. The forest never looks bare, never pauses its work. It is always becoming something new, leaf by leaf, branch by branch. Forest roots can spread farther than the trees are tall. What we see above ground is only a fraction of a tree's true size. Below the surface, roots can stretch outward 2 to 3 times the width of the canopy. In forests, these roots interlace with those of neighboring trees, sharing space water and sometimes nutrients. This underground spread helps trees remain stable in storms and access scarce resources. It also means a forest is deeply interconnected at levels we never see. The strength of one tree is often supported by many others beneath the soil. Some forests are older than entire mountain ranges. While mountains rise and erode over geological time, some forests have persisted through those changes, shifting location and composition but never disappearing entirely. Tree lineages can outlast continents in their current forms, adapting to new climates as the planet reshapes itself. The forest you walk through today may be the descendant of forests that stood when mountains were lower seas, were closer, and climates were utterly different. In that sense, forests are not just places, they are living histories written across deep time. And as this long walk among the trees continues, the pace naturally slows. The forest does not hurry. It layers time gently. It teaches patience without words. You may imagine now the quiet settling of leaves after dusk, roots drawing water in the dark, canopies whispering to clouds above. If your thoughts begin to soften, let them drift between trunks and shadows. The forest will remain, breathing, waiting, and when you are ready to rest, it will still be there, holding its stories unchanged by sleep and endless as time itself. Over time, these volcanic forests become layered records of past eruptions. Charcoal buried in the soil marks ancient fires. Bands of ash form invisible timelines beneath the roots. To walk through such a forest is to walk on a history of explosions and renewal, where danger and abundance exist side by side, and where life has learned to grow directly on the memory of catastrophe. Some forests grow where it never truly gets dark. In far northern regions, near the Arctic Circle, forests experience weeks or even months of continuous daylight during summer. The sun circles the horizon without setting bathing trees in a constant glow. During this time, photosynthesis runs almost nonstop. Trees grow rapidly, taking advantage of every hour of light. In winter, the opposite happens. Darkness can last for weeks. Growth slows almost to nothing as trees enter deep dormancy, conserving energy until the sun returns. This extreme cycle creates forests that live at the edge of possibility, stretching the limits of what trees can endure. Their existence shows how life adapts not just to warmth and cold, but to light itself. Some forests can regrow after being completely destroyed. Forests have an astonishing ability to return even after seeming annihilation. After volcanic eruptions, massive fires, hurricanes, or clear-cutting forests often come back, sometimes within decades. Seeds buried deep in the soil survive. Roots send up new shoots. Wind and animals bring in new life from surrounding areas. This process, called ecological succession, follows a quiet order. First, Mosses and grasses appear, then shrubs, then fast growing trees. Over time, a mature forest returns often different from before, but alive once more. What looks like an ending is often a pause between chapters. Forests remember how to rebuild. Some trees can clone themselves to survive. In many forests, not every tree begins as a seed. Some spread by cloning, sending up new trunks from shared root systems. Aspen forests are famous for this. What looks like thousands of individual trees may actually be one organism connected and underground. This strategy allows forests to persist even when seeds fail. If one trunk dies, others rise in its place. The forest becomes nearly immortal, renewing itself without starting over. In these groves, death is local, but life continues uninterrupted. Forests can influence how rivers flow. Tree roots stabilize soil along riverbanks, slowing erosion and shaping the curves of rivers over time. Fallen trees redirect currents, creating pools and rapids that become habitats for fish and insects. Without forests, rivers tend to run straighter, faster, and more destructively. In forested landscapes, water moves gently filtered and slowed. Floods are softened. Sediments are trapped. The forest teaches water patience, guiding it across the land rather than letting it rush away. And slowly our journey through the forest continues. From drifting islands to underwater canopies, from fire-borne soil to roots older than mountains, each fact is not separate but woven together like branches overhead. The deeper you walk, the quieter it becomes. The quieter it becomes, the more the forest seems to breathe with you. If your thoughts are beginning to slow, let them rest here for a moment, under leaves that have witnessed centuries, above soil alive with unseen worlds. The forest does not rush you, it never has. And whether you stay awake a little longer or drift gently toward sleep, the trees will remain standing, breathing patient as ever. Over decades, these young forests begin to take on lives of their own. Shrubs appear beneath the trees. Birds return. Insects follow. What starts as rows of planted saplings slowly becomes something wilder, less predictable, and more alive. Forest recovery is not a reversal of the past, but the beginning of a new chapter. It shows that while damage can be done quickly, healing, though slower, is still possible. Some forests remember human activity for centuries. Even long after people leave forests, carry subtle records of what once happened there. Old charcoal layers in the soil reveal ancient fires set by humans. Unusual clusters of fruit trees may mark the sites of forgotten villages. Straight lines in the forest, visible only from the air, can trace the paths of Roman roads or medieval boundaries. In Europe and Asia, scientists have found that many wild forests are actually shaped by agriculture, abandoned hundreds or even thousands of years ago. The forest grows over our footprints, but it does not erase them completely. Instead, it weaves them into its own story, turning human history into part of the ecosystem itself. Forests can slow the spread of disease. Healthy forests often act as buffers against disease outbreaks. Diverse ecosystems support predators that keep disease-carrying animals in check. When forests are intact, pathogens have fewer chances to dominate. Studies suggest that deforestation can increase the risk of certain diseases spreading to humans by disrupting these natural controls. In this way, forests quietly protect not just wildlife, but human communities as well. Their complexity becomes a form of defense, built not from walls, but from balance. Some forests have sounds that change with altitude. As you climb through a mountainous forest, the soundscape shifts. Lower elevations may hum with insects and flowing water. Higher up, the air grows thinner and quieter. Bird calls become sharper. Wind replaces buzzing wings. These changes affect how animals communicate and how humans experience the forest. Sound travels differently among dense leaves than among sparse alpine trees. Each elevation has its own acoustic signature, a layered music shaped by height, temperature, and life itself. Forests can influence how long clouds last. Clouds drifting over forests often behave differently than those over bare land. The moisture and aerosols released by trees can help clouds persist longer, reflecting sunlight and cooling the surface below. This extended cloud cover can moderate temperatures and reduce heat extremes. Over large forests, the effect can shape regional climate patterns, softening the harsh edges of weather. Trees, in this sense, act like quiet climate engineers, adjusting the sky above them. Some forests exist only because of animals. In certain ecosystems, forests would not exist at all without animals. Large seed dispersers like elephants, tapirs, and large birds carry seeds far beyond the reach of gravity or wind. When these animals disappear, forests can fail to regenerate properly. Tree species that rely on them slowly vanish. The forest changes shape, becoming simpler and less resilient. It is a reminder that forests are not just collections of plants, but partnerships between roots, wings, hooves, and teeth. Forests can be older than the mountains around them. Some forests predate the landscapes they inhabit. As mountains slowly rise through tectonic forces, forests adapt and persist, migrating upward or outward as conditions change. Genetic studies reveal tree lineages that have survived through mountain formation ice ages and shifting continents. These forests are witnesses to deep time living archives that have endured while the ground beneath them slowly reshaped itself. And slowly our walk through the forest draws toward another quiet clearing. We've passed through fire and frost myth and science, soil and sky. We've seen forests as builders of climate, keepers of memory, and partners in life. If your thoughts are drifting now, let them wander beneath these trees. Let the canopy close softly overhead. Let the forest do what it has always done best: hold, protect, and wait. The trees are in no hurry, and neither are you. Isolation creates uniqueness. When forests are cut off by oceans, mountains, or vast stretches of unsuitable land, life inside them begins to follow its own path. Over thousands or millions of years, plants and animals adapt so precisely to their surroundings that they exist nowhere else on Earth. These endemic species may be found in a single valley, on one mountain slope, or within the borders of a single forest. Madagascar's forests are a striking example. The vast majority of their plants and animals, from towering baobabs to lemurs, evolved in isolation. Similar patterns appear in cloud forests, island jungles, and ancient woodland refuges around the world. Such forests are irreplaceable. When they disappear, entire branches of the tree of life vanish with them. Their existence reminds us that forests are not interchangeable. Each one is a unique experiment of evolution shaped by place, time, and chance. Some forests change shape with the seasons. Forests are often imagined as constant, but many transform dramatically throughout the year. In monsoon regions, forests burst into dense greenery during wet months only to thin and quiet during dry seasons. In temperate zones, leaves unfurl, darken blaze with color, and fall, altering light, sound, and movement beneath the canopy. Animals time their lives to these rhythms. Insects emerge with new leaves. Birds arrive when fruit ripens. Mammals follow the pulse of abundance and scarcity. The forest is never frozen in one form. It is always becoming something else, guided by cycles older than memory. Some forests exist entirely underground. Not all forests grow toward the sky. In caves and lava tubes, communities of fungi roots and microbes form underground forests, fed not by sunlight, but by minerals and organic matter seeping from above. Tree roots penetrate ceilings and walls, branching through darkness in search of moisture and nutrients. These hidden forests play quiet roles stabilizing soil, filtering water, and supporting specialized life adapted to perpetual night. They remind us that forests are not defined by light alone. They are defined by connection growth and persistence, even in places where the sun never reaches. Forests can survive without rain for years. In some dry regions, forests persist through extraordinary droughts. Trees tap deep groundwater store moisture in their tissues or shed leaves to reduce water loss. Some species can shut down growth almost entirely, waiting patiently for rain to return. These drought-adapted forests may look sparse or still, but they are alive with strategy. When rain finally comes, they awaken rapidly, flowering and leafing out as if time had merely paused. Their survival shows us that forests are not always lush. Sometimes they are quiet, restrained, and enduring. Forests influence how humans settle the land. Throughout history, forests have guided where people live, farm, and build. They provide wood food, water regulation, and protection from extreme weather. Many of the world's great cities began at forest edges, where resources were abundant, but land was still open. Even today, forest presence influences climate comfort, water security, and economic stability. When forests vanish, communities often face floods, droughts, and soil loss. The bond between humans and forests is not accidental. It is deeply practical, shaped by survival as much as culture. Forests can outlive empires. Human civilizations rise and fall in centuries. Forests think in millennia. Some woodlands have stood through the birth and collapse of empires, quietly reclaiming roads, walls, and cities when people moved on. Stone crumbles, names fade, but roots keep growing. Forests do not remember history as stories, they remember it as soil layers, charcoal traces, and altered species patterns. In time, They fold everything back into themselves, and slowly this journey through forests comes toward rest. From underground fungi to drifting clouds, from ancient trees to newborn groves, forests reveal themselves as more than landscapes. They are processes, relationships, living systems that breathe, remember, and adapt. If your thoughts are slowing now, let them settle beneath the canopy. Imagine leaves whispering above you, roots holding the ground steady below. Forests do not rush. They wait. They grow. They endure. And as you rest, they continue their quiet work, shaping the world, one breath, one leaf, one year at a time. This nighttime symphony is not chaos. Each species times its calls to avoid overlap, carving out an acoustic niche so it can be heard. The forest becomes a living sound map where communication replaces sight and darkness sharpens every note. To human ears, it can feel overwhelming at first. But listen long enough and patterns emerge, rhythms repeat, voices answer one another. The forest at night is not noisy by accident. It is alive with coordination, a reminder that even in darkness, life is deeply organized. Some forests never experience complete darkness. In far northern regions during summer, forests bathe in continuous daylight. The sun dips low, but never fully sets, casting long golden shadows through birch and pine. Birds sing through the night. Plants photosynthesize without pause. Time itself seems to stretch, blurring day and night into one long glow. For animals and people alike, these forests alter sleep cycles and behavior. Growth accelerates. Activity extends. When winter finally returns, darkness comes back just as completely, lasting for months. These extreme shifts shape life in ways few other ecosystems do. The forest adapts, slowing and waiting, then surging forward again when light returns. Some forests grow in total silence after snowfall. When snow falls thickly in a forest, sound seems to vanish. Snow absorbs vibrations, softening footsteps, muting wind, and dampening distant noise. The result is a deep, almost physical quiet. Even animals move differently, conserving energy and slipping carefully between trees. This silence is not emptiness. Beneath the snow, roots remain active. Seeds wait. Insects shelter. The forest enters a suspended state, conserving life until warmth returns. For humans, standing in such a forest can feel like stepping outside of time, where even thoughts slow to match the hush. Forests remember fires long after flames are gone. Decades after a fire, its memory remains written in the forest. Charcoal enriches the soil. Certain plants sprout only where fire once passed. Tree rings record scars from heat and smoke, marking the year with dark lines. Even animal populations shift in response to the changed landscape. These memories guide the forest's future. Species that thrive after fire gain ground. Others retreat. The forest does not erase disturbance. It absorbs it, weaving destruction into renewal. In this way, fire becomes part of the forest's long story, not an interruption, but a chapter. Some forests slow time for those who enter them. People often report that time feels different beneath dense canopies. Minutes stretch, worries soften, attention turns inward. Scientists suggest this may come from reduced visual overload, rhythmic natural sounds, and chemical compounds in forest air that calm the nervous system. Whatever the cause, forests have long been places of reflection, ritual, and retreat. Across cultures, they appear in myths as thresholds between worlds, not because they are unreal, but because they change how we perceive reality itself. And as this gentle walk through forests continues, one truth becomes clear. Forests are not just collections of trees. They are memory, motion, chemistry, sound, and time interwoven. They whisper weather, they sculpt air and water, they shelter life seen and unseen. If your breathing is slow, now let it match the forest's pace, unhurried, patient, enduring. The forest will keep growing whether we watch or sleep, and when you wake, it will still be there, quietly shaping the world, one leaf, one root, one breath at a time. Deep within ancient forests lie clues to the earliest chapters of life on land. Some forest soils preserve living lineages that have changed very little for hundreds of millions of years. Primitive mosses, liverworts, and fungi resemble some of the first plants to ever colonize Earth's surface, helping transform bare rock into living soil. These early pioneers paved the way for trees, insects, and animals to follow. Fossil evidence shows that the first forests dramatically altered the planet. They pulled carbon dioxide from the air, stabilized soils, and reshaped rivers. In doing so, they cooled the climate and made Earth more hospitable for complex life. When you walk through an old forest today, you are stepping into a system whose roots reach back to a time before dinosaurs, before birds, before flowers. The forest is not just ancient in age, but ancient in memory, carrying echoes of life's earliest experiments. Some forests act as living archives of climate history. Trees quietly record the story of the world in their rings. Each year of growth leaves behind a mark shaped by rainfall, temperature, fire, and drought. By studying these rings, scientists can read centuries, even thousands of years of climate history. Periods of abundance appear as wide rings. Years of hardship narrow into tight lines. In ancient forests, these records stretch far beyond written history. They reveal past ice ages, volcanic eruptions, and long forgotten droughts. In this way, forests become timekeepers, preserving the memory of Earth's changing moods. Long after storms have passed and civilizations have risen and fallen, trees still hold the evidence in their silent cores. Forests can outlive entire civilizations. Human societies rise, flourish, and fade often within the lifespan of a single forest. Ancient woodlands have stood through empires, migrations, and wars. Roads vanish beneath roots. Stone walls crumble and disappear under moss. Languages change. Borders shift. Yet the forest remains adapting slowly, absorbing human traces and reclaiming space. In many places, trees now grow where cities once stood their roots, threading through forgotten foundations. Forests remind us that while human history feels vast, it is brief compared to the quiet endurance of living landscapes. Some forests protect species during mass extinctions. Throughout Earth's history, Mass extinctions have wiped out enormous portions of life. Yet forests often served as refuges, places where species could retreat and survive. Dense vegetation, stable humidity, and complex food webs provided shelter during times of extreme change. After catastrophe passed, life expanded outward again from these green sanctuaries. This is why forests today hold such deep reservoirs of biodiversity. They are not only places of growth, but places of survival, keeping life alive through the planet's darkest chapters. Forests slow the pace of the world. Under a canopy of leaves, the rush of modern life fades. Light softens. Sounds layer gently instead of colliding. Movements become deliberate. Even breathing changes, deepening without effort. There is a reason humans across cultures have sought forests for reflection, healing, and ritual. The forest does not hurry. It grows on timescales that resist urgency. To be among trees is to be reminded that not everything must move fast to matter. And as this journey through forest truths gently continues, one understanding settles in. Forests are not background scenery. They are living processes. They are memory made of wood and leaf. They are sound turned into shelter. They are time moving slowly enough for life to adapt. If your thoughts feel quieter, now let them rest there, like leaves settling after wind, like insects pausing between songs. The forest will keep breathing through the night, and whenever you return awake or dreaming, it will be waiting, rooted, patient, and endlessly alive. Some forest trees produce their own insect repellent. To survive in a world filled with hungry insects, many trees have evolved their own chemical defenses. Leaves, bark, and sap can contain compounds that taste bitter, disrupt insect digestion, or interfere with their ability to reproduce. These natural repellents help protect the tree without the need to grow thicker armor or expend extra energy on repairs. Neem trees, for example, produce oils that deter a wide range of insects, while eucalyptus leaves contain aromatic chemicals that discourage feeding. In some cases, these substances are released into the air, creating a protective cloud around the tree. Humans have learned from these strategies using plant compounds in natural pesticides and medicines. What smells pleasant to us can be a powerful warning to insects. The forest is in this way a vast chemical landscape where survival depends not only on strength or size, but on subtle molecular signals drifting through the air. Some forests can recover astonishingly fast after destruction. When a forest is burned, flooded, or logged, it may look ruined beyond repair. Yet many forests are remarkably resilient. Seeds buried in the soil can remain dormant for decades, waiting for light to return. Roots of fallen trees can sprout new shoots. Nearby forests send seeds carried by wind birds and insects. In tropical regions, green shoots can appear within weeks of devastation. Vines climb first, followed by fast-growing pioneer trees that prepare the ground for slower, longer-lived species. Over time, layers rebuild. Shade returns. Animals follow. While full recovery can take centuries, the first signs of rebirth often come quickly. Forests carry within them the instructions for renewal, ready to begin again when conditions allow. Some forests are older than entire mountain ranges. While mountains rise and erode over millions of years, some forests persist through these changes, shifting slowly but continuously across the landscape. As glaciers advance and retreat, forests migrate. As continents move, forests adapt. Lineages of trees can outlast the shapes of the land itself. This endurance means forests are witnesses to Earth's slow transformations. They have lived through changing climates, drifting continents, and altered skies. To stand in an ancient forest is to stand among beings that have outlived valleys, rivers, and even mountains as we know them. Forests shape the future as much as they preserve the past. Beyond holding memory, forests actively influence what comes next. They regulate climate, guide evolution, and create conditions for new life to emerge. Each seedling growing in shade is a possibility. Each fallen tree becomes nourishment for something yet to be. The future of forests is intertwined with the future of life itself. As climates shift and pressures grow, forests will continue to adapt just as they always have. Some will shrink, others will expand. New forests will rise where none existed before. And so the story continues, quietly, rooted in soil, written in leaves, wind, and time. As you rest now, you might imagine the slow spread of roots beneath the ground, the patient exchange of signals in darkness, and the steady breath of a forest that has been alive far longer than any one moment. The forest does not hurry. Neither do you need to. Let the story fade softly into the trees. In return, the living stump may help stabilize soil or share nutrients when conditions change. This quiet exchange happens through intertwined roots and fungal threads invisible above ground. It means survival in a forest is often collective rather than individual. Trees that stand together endure together, sharing strength across generations. Some forests act as natural libraries of medicine. Deep within forest ecosystems grow plants that have shaped human medicine for centuries. From willow bark, which led to aspirin, to quinine, from cinchona trees used to treat malaria, forests have long been sources of healing. Many modern drugs trace their origins to compounds first discovered in forest plants and fungi. Even today, scientists believe vast numbers of potential medicines remain undiscovered, hidden in leaves, roots, and spores. Indigenous communities often hold detailed knowledge of these medicinal forests passed down through generations. Each plant carries a story, a use, a warning. Forests are not only places of life, but repositories of cures, quietly holding chemical blueprints that may one day save lives. Forests can soften the sound of the world. Step from an open field into a forest, and the noise fades. Trees absorb and scatter sound waves, reducing echoes and dampening harsh noise. Leaves, bark, and soil act like natural acoustic panels, turning sharp sounds into softer murmurs. This is why forests feel hushed even when full of life. This sound buffering protects animals, allowing subtle calls and movements to be heard without interference. For humans, it creates a sense of calm, as if the forest wraps the world in quiet. In a noisy planet, forests offer one of the last true refuges of gentle sound. Some forests protect cities from floods. Forests play a powerful role in controlling water. Tree roots anchor soil, preventing erosion. Canopies slow rainfall, allowing water to soak gradually into the ground. In river basins, forested areas reduce the risk of floods by absorbing and releasing water slowly over time. When forests are cleared, rain rushes directly into rivers, causing sudden surges that can overwhelm cities downstream. Where forests remain intact, floods are gentler soils, richer, and waterways more stable. In this way, forests quietly protect human settlements, standing upstream as guardians against water's destructive force. Forests remember disturbance for generations. Even long after fires, stormstorms, or logging forests carry memory of what happened. Tree rings record years of drought or abundance. Soil composition shifts, species balance changes. These memories shape how the forest responds next time. A forest that has burned before may regenerate faster. One that endured drought may grow differently afterward. This ecological memory allows forests to adapt, learning from past stress without conscious thought. It is resilience written not in minds, but in growth patterns, root systems, and seed banks. And so the forest continues, defending, sharing, remembering. Every tree, every leaf, every unseen exchange is part of a long conversation that has been unfolding for millions of years. As you listen now, you are not outside that story. You are breathing with it, resting alongside it, held gently within its rhythm. Let the forest keep speaking. You don't need to answer. Recent research suggests forests may be cooling the planet more than we once realized. Beyond storing carbon, their influence reaches into the physics of heat itself. When trees release water vapor into the air, that moisture absorbs energy as it evaporates, pulling heat away from the land. At the same time, the clouds formed from this vapor reflect a portion of sunlight back into space. Together, these processes act like a vast natural cooling system spread across continents. In heavily forested regions, temperatures can remain noticeably lower than in nearby deforested areas. This means forests do not simply respond to climate change, they actively moderate it, shaping how warm the planet becomes. Forests also influence how long heat stays in the atmosphere. By altering cloud cover and air circulation, they affect how quickly warmth escapes back into space at night. In tropical regions, dense forests help prevent extreme daytime heating while slowing nighttime cooling, keeping temperatures more stable. This balance creates environments where life can thrive without constant stress from temperature swings. Without forests, land heats faster, cools faster, and becomes more hostile to life. Some forests act as long-term climate memory systems. The soil beneath ancient forests stores records of past climates in layers of organic material. Pollen grains, charcoal fragments, and chemical signatures preserved underground allow scientists to reconstruct what forests looked like thousands of years ago. These records reveal how forests expanded during warm periods, contracted during cold ones, and adapted to shifts in rainfall. In this way, forests do not only shape the present climate, they remember the past, offering clues about how Earth responds to change over time. Forests can delay the effects of extreme weather. When heavy rains fall, forest soils absorb and slow the movement of water, reducing floods downstream. During droughts, deep roots tap into stored moisture, keeping landscapes alive longer than open land could manage. Even during heat waves, forests maintain cooler, more humid conditions that act as refuges for plants, animals, and people. This buffering effect can mean the difference between survival and collapse during extreme events. Forests influence how storms form and move. Large forested regions alter pressure patterns in the atmosphere, subtly steering storm tracks. Moist air drawn inland by forests can feed storms hundreds of kilometers away. In some cases, the presence or absence of forests determines whether rain reaches agricultural regions or dissipates over dry land. This means forests participate in shaping not only local weather, but the fate of distant ecosystems and human communities. Forests are deeply tied to the future of climate stability. As global temperatures rise intact, forests become increasingly valuable. They cool, store, carbon regulate water, and maintain biodiversity all at once. Losing them weakens multiple systems simultaneously. Protecting them strengthens resilience across the planet. Forests are not a single solution, but they are one of the few systems that address many challenges at the same time. And beneath all of this science lies something quieter. Forests operate slowly, they respond gradually. Their strength comes from persistence rather than force. In a world of rapid change, they offer continuity. Their processes unfold whether or not we are watching leaf by leaf, root by root, breath by breath. In a warming world, forests are no longer seen only as victims of climate change, but as essential allies against it. Every tree participates in a vast planetary cooling system that works quietly and continuously. The cool shade we feel beneath a canopy is only a small local expression of a much larger process unfolding across continents. Through moisture, carbon storage, and cloud formation, forests soften the planet's rising heat day after day. Their work is invisible to most of us, yet without it, the world would warm far faster. Every forest exists in more than one time at once. Some trees standing today began growing centuries or even millennia ago, while new seedlings push through the soil each season. Beneath them, the ground holds traces of forests that lived millions of years earlier, compressed into layers of soil and stone. At the same time, young leaves prepare the canopy that will shape decades to come. A forest is both memory and momentum, ancient in its foundations and new in its constant renewal. Walking through a forest means moving through overlapping generations. Life cycles do not replace one another cleanly, they coexist. Old trunks stand beside saplings. Fallen trees nourish new growth. Time feels less linear here, more layered, as if past and future are woven together among roots and branches. Forests are never finished, they are always becoming. Despite how familiar they may feel, forests still hold countless mysteries. Each year, scientists identify new species of insects, fungi, and plants, many of which lived unnoticed for centuries. The full complexity of underground fungal networks is still being uncovered. The precise ways forests regulate climate exchange chemicals with the atmosphere and influence distant ecosystems remain only partly understood. Even in the most studied forests on Earth, much of life operates beyond our current knowledge. In this sense, forests remain frontiers, as rich in unanswered questions as deep oceans or distant planets. They challenge our understanding of cooperation, resilience, and adaptation. Every walk beneath a canopy passes through systems far older and more intricate than we can fully grasp. Some forests contain trees that seem almost mythic in their appearance. In parts of Africa, South America, and Asia, certain species release sap so deeply red it resembles flowing blood. The most famous of these is the dragon blood tree of Socotra, whose thick crimson resin has been used for medicine dyes and rituals for thousands of years. When its bark is cut, the red sap emerges slowly, giving the impression that the tree itself is wounded. To ancient cultures, these trees appeared alive in an especially powerful way, as though their lifeblood had been revealed. Today, science offers another perspective. The red resins contain complex compounds that protect the tree from infection and pests. Many show antibacterial and antifungal properties, confirming that what once seemed mystical also serves a precise biological purpose. These trees remind us that forests have always existed at the boundary between wonder and explanation, between myth and molecule. What once inspired legend now inspires research, yet the sense of awe remains. Even with knowledge, forests continue to feel alive in ways that go beyond simple description. What may look strange or even unsettling is simply a tree's way of surviving. That deep red sap is not a sign of harm, but of healing. It seals wounds, blocks infection, and protects the living tissue beneath the bark. In this quiet way, forests bleed, repair themselves, and endure. Even without movement or sound, they respond to injury with remarkable efficiency, reminding us that stillness does not mean fragility. Some rainforest trees rise higher than the Statue of Liberty. Deep within the Amazon, a small number of extraordinary trees soar above the rest of the canopy, reaching heights of more than 80 meters. These emergent giants, including species like Denitzia excelsa, stand taller than most human-made monuments. From a distance, they appear like solitary towers rising from an endless green ocean. By reaching above the canopy, they capture sunlight unavailable to most other trees, giving them a powerful advantage. Their height also makes them ecological pillars. Entire communities of birds, insects, and epiphytic plants live among their upper branches, rarely descending to the forest below. These trees store vast amounts of carbon, locking it away in their massive trunks and reinforcing the forest's role in regulating climate. To stand beneath one is to feel the same sense of scale and awe as looking up at a skyscraper, with one profound difference. This structure is alive, grown slowly from soil, rain, and time. The largest known tree by volume outweighs fleets of blue whales. In California's Sierra Nevada stands the General Sherman tree, a giant sequoia that holds the record for the largest living tree by volume on Earth. Its trunk alone contains more than 1,000 cubic meters of wood. By mass, it outweighs dozens of blue whales combined. Yet, it is neither the tallest tree nor the oldest, a reminder that forests hold many kinds of giants, each remarkable in its own way. The General Sherman reached its immense size through patience rather than speed. Over thousands of years, layer upon layer of living tissue accumulated, building a vast column of wood that continues to grow even today. At its base, humans seem impossibly small, like fleeting visitors, beside something permanent. This single tree functions almost like a forest itself, hosting mosses, birds, insects, and microorganisms that all depend on its presence. For more than 2,000 years, it has stood quietly, a living monument shaped not by hands, but by time. Bamboo is among the fastest growing plants on Earth. Some species can grow nearly a meter in a single day, a rate so fast that it can be measured by watching the plant over hours rather than years. This rapid growth allows bamboo forests to recover quickly after disturbance, making them one of the most renewable biological resources on the planet. Unlike trees, bamboo is a grass, yet it forms dense forests that rival woodlands in height and structure. Its hollow, segmented stalks give bamboo a rare combination of strength and flexibility. These qualities have made it invaluable to humans for thousands of years, used in construction tools, weaving paper and food. In nature, its speed gives it a different advantage. Where other plants take decades to return, bamboo can reclaim space in weeks, turning sunlight and water into towering green walls almost overnight. In this contrast between the slow patience of ancient trees and the explosive growth of bamboo forests, reveal one of their deepest truths. There is no single way to endure. Life survives through many strategies, all unfolding quietly beneath the canopy. These ancient forests shaped the atmosphere itself. During the Carboniferous period, their immense growth drew vast amounts of carbon dioxide out of the air, helping raise oxygen levels to heights never seen again. Giant insects thrived, and Earth's climate shifted under the influence of trees that stretched from horizon to horizon. Though continents later fractured and climates changed, the legacy of those primeval forests remains locked in coal seams and fossilized trunks, silent evidence that forests once ruled nearly every corner of the land. Forests were among the first architects of breathable air. Before forests spread across the continents, Earth's atmosphere was far less friendly to complex life. Early trees and their ancestors played a crucial role in transforming it. Through photosynthesis, they absorbed carbon dioxide and released oxygen, gradually reshaping the chemistry of the sky. Over millions of years, this steady process made it possible for animals, including eventually humans, to breathe freely. Forests did not just adapt to the planet, they changed it, preparing the world for the diversity of life that would follow. Some forests exist entirely in silence beneath snow. In the far north, boreal forests spend much of the year locked under snow and ice. Sound is muffled, movement slows. Yet beneath the snow, life continues. Roots remain alive, microbes stay active in the soil, and animals tunnel through hidden passages. Trees enter a deep dormancy, conserving energy until sunlight returns. When spring arrives, the forest awakens rapidly, erupting with growth and sound in a brief but intense season. These silent winters show another side of forest resilience: survival through stillness. Forests can remember past climates. The composition of a forest often reflects conditions that no longer exist. Species distributions, soil layers, and genetic patterns all carry traces of ancient climates. Some trees growing today are descendants of populations that survived ice ages in isolated refuges. Others migrated slowly across continents as temperatures warmed. In this way, forests hold memory not just in tree rings, but in their very makeup. To study a forest is to read a long environmental history written in leaves, roots, and genes. Forests influence how humans feel time. People often describe time passing differently in forests. Minutes feel longer, thoughts slow. This may be partly biological, as natural environments reduce stress and calm the nervous system, but it is also symbolic. Forests surround us with organisms that live on time scales far beyond a human life. Standing among trees that began growing before modern nations existed shifts perspective. Worries shrink, urgency softens. In a forest, time feels layered rather than linear, inviting reflection rather than haste. Forests continue to shape the future of life on Earth. As the planet warms and climates shift, forests will again play a decisive role. Some will retreat. Others will expand into new regions. Species will migrate, adapt, or vanish. At the same time, forests remain one of humanity's greatest allies, storing carbon, cooling landscapes, regulating water, and supporting life at every scale. Their future is inseparable from our own. And so, as this gentle journey through the world of forests continues, one truth becomes clear. Forests are not merely collections of trees. They are living systems that shape land, air, water, time, and even the human mind. Ancient, yet ever changing, fragile, yet powerful, they stand as quiet witnesses to Earth's past and active participants in its future. As you rest now, you might imagine the slow creak of trunks in the wind, the soft drip of water from leaves, or the deep, patient breathing of roots beneath the soil. The forest continues its work unseen, steady, and timeless, whether we are awake to notice it or drifting gently into sleep. Those ancient global forests help sculpt the very air of the planet. By drawing vast amounts of carbon dioxide from the atmosphere, they raised oxygen levels far higher than we know today, creating conditions where giant insects and early amphibians could thrive. As climates shifted and continents slowly drifted apart, those endless green expanses fractured into the diverse ecosystems we see now. Yet the imprint of that world remains. There was a time when Earth was almost entirely forest, a green planet where trees shaped land, sky, and life itself. Forests also remind us how temporary human creations truly are. Cities, roads, and monuments often feel permanent, but time tells a different story. When places are abandoned, forests return. Roots pry apart concrete. Vines climb through broken windows. Branches lean over fallen walls. Even the grandest human structures eventually soften under the slow persistence of growth. Forests move patiently, but their endurance surpasses stone. Civilizations rise and fade in centuries. Forests think in millennia. Given enough time, they erase scars and quietly reclaim the land. This is why forests embody one of nature's deepest truths. Life is fragile in the moment, yet astonishingly resilient over time. A forest can burn, be cut, or disappear within a single generation. And still, decades later, green shoots return. Seeds buried in the soil awaken. Birds and insects follow. What was once silence fills again with movement and sound. A seedling may be delicate enough to crush underfoot, yet with time, it can grow into a giant that stands for centuries. Forests live in this paradox, vulnerable and fierce at once. As we come to the end of this gentle journey through Earth's forests, I hope you felt the quiet calm of walking beneath their canopies, even if only in your imagination. From towering redwoods reaching into misty skies, to the hidden fungal networks beneath the soil, to the memories written in every tree ring, forests show us how intricate and enduring life can be. They are ancient and new, mysterious and familiar, distant and yet always close, because forests are never truly far away. Every breath of air, every sip of fresh water, every steady heartbeat carries their influence. They are the living memory of this planet and one of its greatest hopes for the future. If this journey brought you a sense of calm, you're welcome to like or subscribe to the Sleep Science Space, or leave a gentle thought in the comments. Each small gesture helps guide another quiet soul here. But for now, there is nothing you need to do. Let your breathing slow. Let your body grow heavy against the bed. Allow the presence of forests to remain with you as like a soft green canopy, sheltering your thoughts from the day. Sleep comes more easily when we release our hold. So drift gently into rest. Tomorrow can wait. Tonight belongs to stillness. And when you wake, the forests and the next quiet journey will still be here. Good night.